gonna say time. Like the position they are is so different that if that train is going, that it's, I don't know how to explain it.
Right. Slightly different point of view. I've already told you that the light will be green.
Yeah.
Mm-hmm.
Sue is absolutely right. So I have these two events that go off. Sue says, I know that they went off at the exact same time. We've gone through the logic already. The light will be green. Lou is correct. Those things are not moving relative to him. So how is it that this light gets there first from Lou's point of view if neither of these are moving?
Is it a shorter distance?
No, not a shorter distance.
Okay.
Because that sensor is right smack dab in the middle, in between the two. And this kind of mind-bending stuff is what I really like about relativity.
Does this correlate with something in physics 251?
Say it again?
Does this correlate with something in physics 251? It being on the train and like, not the perspective of no movement?
No, the 251 typically deals with Galilean relativity, and this is definitely not Galilean relativity.
Is it kind of like sound? Like you might hear it at a distance, and there might be like a latency before somebody else hears it?
No, but well, eventually when we get to we'll get to the conceptual solution to this before we go, then we'll get into the mathematics of it, and then we can talk about the idea of when things are perceived versus when things happen, which is a clue to what's going on here. Let's go to violence. All right, I got my brother sitting right here, and I'm going to smack his face. And either both hands are going to hit him at the same time, or one hand's going to hit him first. One hand will hit him first. If I tell you that my left hand hits him first, before my right hand, even though someone swears they happen at the same time, if this one hits him first, what must be true? My hands go at the exact same speed. If this one hits him first,
He's towards the left hand more. He's towards your left hand more, I guess.
okay. My analogy didn't quite work. I didn't word it properly.
Okay.
If my hands are equidistant from his face, and they move at the exact same speed, and my left hand hits him first, what has to be true?
He moved towards your left.
Not that he moved into it. I didn't hear what you said.
No, I said the same thing, he moved towards the left to dodge the right.
He's smack dab in the middle.
Say it again.
How?
My hands are going to move at the exact same speed, the same distance into his face. If my left hand hits him first before my right hand does, how can that happen?
You're not centered.
Not a matter of my hands are still traveling the same distance, the same speed.
And he's not moving in any way.
He's not moving.
He's in the center.
You're wrong.
Who was wrong?
Either way, I smacked my brother in the face, so it's a win no matter what.
His face is turned.
Not a matter of his orientation.
If distance is the same and rate's the same, then time has to be different.
The time it would take for each hand to get there is the same.
You're not actually centered?
Say it? What'd you say?
You're not actually centered?
No, it's still not a matter of my position. And I recognize some of the language that I've used has been misleading, but you've made an assumption in this problem that it's very difficult to break out of.
That was the problem again.
He smacked his brother.
The brother smacking one?
No,
This one.
Oh.
All right, so Sue sees this thing go by, sees the two flashes go off at the exact same time, and the light is traveling towards the sensor in the middle of the train. This light will get there first because that sensor is heading towards it from Sue's point of view, and so this light will hit the sensor first, the light will be green. From Lou's point of view, he says neither of them are moving. If they go off at the exact same time, the light will then hit the sensor at the exact same time, and so the sensor will be red. And then I drop back on the brother smacking one with, I have two hands and I'm gonna smack my brother in the face. If the hands are the same distance from his face, regardless of how he's oriented, if my hands are the same distance from his face and my hands travel at the exact same speed for the exact same amount of time to get to his face, and this one gets there first, how is that possible?
He's centered. Your brother's centered.
My hands are the same distance from him.
At the same speed, there's not a force on your other arm restricting it to go back.
Correct, not there. My hands will travel the exact same speed, the exact same distance for the exact same amount of time,
No.
but this hand gets there first.
Your opinion?
No, he said no way.
And there's no forces opposing your right hand.
Correct.
I mean, that wouldn't matter.
If I take these two markers and I drop them and this one hits the ground first, how is that possible?
It's heavy.
No.
One hand releases before the other.
Yes, that's the key. The way that I get my brother first with this hand is that I move this hand before I start moving this hand. The way that this works is, from Sue's point of view, they do go off at the exact same time. But from Lou's point of view, they don't. This side goes off first, and then that one side does. Just because two things happen at the exact same time from one point of view does not mean that they happen at the exact same time from a different point of view. That is the principle of simultaneity, and that ultimately will explain the car in the garage. And that is gonna have to wait until next week.
I'm confused.
Relativity will do that. Wait till you see the equation, then it all becomes clear. That's what math does, right? Clarifies everything.
What did you say the name of the experiment was from the top of the
If you
mountain?
look up simultaneity, there's better drawings than what I have here.
I meant the top of the mountain.
Oh, the Rossi Hall, ROSSIHALL. That was the first one of the muon experiments, and then there've been some others since.
I don't like
I'm not gonna say I haven't seen something like it, but I thought it was just used at a different distance and a different kind of time. So
It's-
it's
We assumed he said the same time, but he only
No.
said distance and speed.
No offense to you, but I'm gonna need some supplemental YouTube
Yeah.
videos.
All right. Well, and you see some of this again on some of the supplemental videos as well, as you go to, under supplemental materials, I think it's like internet resources, there's a document there
I'm not
with
gonna define it.
things that I found.
I don't think he said that.
It's that idea that things don't happen at the same time for everybody. The same events don't happen at the exact same time for everybody is a little bit mind-blowing, I think. The fact that time's not the same for everybody also is a little bit mind-blowing, we got used to it by now.
How does it work with tiny things? Because I was looking online the other day that relativity that doesn't work for like quantum particles and stuff that's really small. You have like a whole other set of like rules. I think it's like quantum mechanics, if I remember correctly.
Okay, yep.
But same thing. How come like that can only apply to that, and relativity can only apply to this? How come they don't?
Quantum relativity?
No, like quantum mechanics. Like I don't know if I read it wrong, but it's like it only works on tiny particles.